Okay, so this is just going to be a quick overview of what we are doing in class on Thursday or Tuesday, depending on which day you are missing. Ideally, you have done the 3 readings on phosphate, and you've done Module 7 notes, so these 2 things will be useful for you as we complete the assignment for today. You're also going to want to find Week 5's folder on Schoology. These are 3 thinking questions that are in one of the documents I'm sharing with you. And what you want to think about when you complete just those broad questions is, this is Lake Champlain, looking at each section of the lake in terms of specific bays or specific areas of the lake. And each lake has a specific TMDL, total maximum daily load of phosphate, that it can't exceed or eutrophication can occur, and we can have really bad ecological and ecosystem effects. Now, each lake has a historical set of data in terms of blue being the safe level and red where those safe levels are exceeded. So in terms of which lake has the biggest or smallest impacts, that might be something that you take a look at more. You also want to think about why it makes sense in terms of human and natural systems to reduce phosphate pollution, and also where we should be focusing our attentions on the phosphate pollution. Should it be on reducing practices that minimize pollution? We would call that proactive environmentalism. Or should we be focusing on technologies that reduce or mitigate the existing problem, which we would certainly call more of a reactionary aspect of environmentalism? So our problem for the next couple days is to really think about how we fix this problem. The cyanobacteria, blue-green algae blooms that are occurring in Lake Champlain that are a result of really poor land management practices and environmental stewardship. There is obvious aesthetic, ecosystem, and even economic implications for this problem in terms of beach closure, loss of revenue for fishing and other aspects of water-based economies, and aesthetically it just looks terrible. And I think as a state we can do a lot better. Now, phosphate is the main source of why eutrophication is occurring in Lake Champlain. Phosphate is a really important fertilizer, and it's primarily used in industrial agriculture. So we can see in this historical graph that in the past we usually used manure as a source of phosphorus, but now we're mining lots and lots of phosphate rock from mines like the one in Morocco that you read about. And at the same time that we really began to increase our phosphate use in terms of rocks, the productivity of wheat, barley, and oats really skyrocketed. So this is the beginning of what we call the Green Revolution in agriculture, where new fertilizers really allowed us to grow a lot more food on the same amount of land, which allows us to feed a lot of people. The problem, though, is that phosphate, unlike nitrogen, can't be synthetically manufactured. So based on our just sort of mining and projections of current and future phosphate use, there's going to be a time very soon, 50, 100 years plus or minus, in which phosphate really runs out. And that could have really dire implications for food productivity, which would also have really big implications for the human population. All of this phosphate generally is lost in different processes, which leads to really big water quality issues. This is Lake Erie right here, another really large lake with some really big problems going on in it. Now, in terms of what we can start thinking about with phosphate use, eutrophication, and the problems that we're going to be addressing, food is one of the big ones. So this is looking at how many grams of phosphate in terms of eutrophication is being used to make equivalent amounts of beef or lamb or cheese or bananas. And really there's some really dirty common foods that create a lot of phosphate pollution. And also generally the more income someone makes, the more their lifestyle relies on fertilizer use, which has some implications as well for environmental problems. So a couple key words that you can define on the first page that I'm giving you: runoff, eutrophication, and anoxic. Runoff is just the idea that when water interacts with surfaces on the earth, especially impervious surfaces like asphalt or pavement or roads, it moves. And as it moves, because of water's really unique characteristics, it dissolves all of the things that it comes into contact, such as manure spread on a field, or fertilizer on a lawn, or if we're looking at wastewater treatment sites, sewage that is within carrying our holding tanks. And all of that runoff tends to enter water bodies. Now, when we have a really rare limiting nutrient like phosphate enter water sources and it causes large spikes in the concentration, because so much biological life relies on phosphorus, we see huge spikes in primary productivity. So phosphorus is used in ATP, proteins, DNA. So really the synthesis of life and the creation of more biomass revolves around the concentration of phosphorus. So huge amounts of phosphates entering the water system causes huge amounts of primary productivity, but just like caffeine, a huge rush of caffeine causes a huge crash. We generally see food systems collapse as a result of that flux, causing our last term anoxic, where everything dies off because of that huge upswing and downswing, causing really oxygen poor waters, which really prevents any ecosystem from rebounding. And we see that with fish die-offs in Lake Champlain. So our goal for the next couple days is to help the Agency of Natural Resources, which has an open public forum right now, for how they should spend $30 million in grant money to help better manage Vermont's water quality. You're going to be proposing solutions to specific problems and locations to help them be really targeted with where they spend that money and how they're spending that money. There are a couple things we want to think about. First, there are 6 main aspects that we can talk about in terms of how and where phosphate is entering the lake in a variety of ways. The first that you want to be aware of is that stormwater runoff and roads are really due to impervious surfaces. They're very they're very urban, and they cause a lot of water entering in places where you would see cities. Alternatively, agricultural runoff is a lot more specific to rural areas. They're usually larger surfaces, and it's generally due to manure runoff. Now, wastewater treatment sites is specific to urban centers that are treating sewage. And generally what happens is during large rainfall events, which Vermont is predicted to have more and more of, the carrying capacity is overwhelmed, and because of that, the wastewater treatment sites have no choice but to dump sewage into rivers. Wetlands are commonly displaced, degraded, or removed when urbanization occurs within Vermont's towns and cities. And wetlands are really good at absorbing excess stormwater runoff and filtering that water to have sedimentation of phosphates occur, which means that the phosphates don't enter the lake or rivers. Fertilizers on things like gardens or lawns or golf courses are also very analogous to agricultural runoff, where that fertilizer doesn't really soak well up into the soil, so any rain event after the application can really lead to lots of fertilizers leaching into water bodies. And then finally, forests, leaf litter, so decomposing leaves, and also clear-cutting forests are 2 large sources of how natural phosphates can enter the lake. With this thing, we're going to be doing 3 steps. The first is to really define and find a problem within ArcGIS in the resource list that I'm giving you. And then next week, we're going to be researching specific aspects of the problem and proposing an action plan for our solution. So I'm going to show you a few things right now that you're going to want to open up to help you start your work. So this is week 5, and this is the water quality solutions. Ideally, you're going to be opening sources, solutions, and the interactive Vermont map. The solutions document is this. Now this is a Jamboard that everyone should have an ownership of a page, and you're really going to be focusing on this today in terms of finding maps and images that allow you to target a specific water body and specific problems associated with that water body that are causing the Lake Champlain water quality to have an adverse effect. Now this is the Inn Brook. I found it on ArcGIS. It has really compromised high levels of phosphorus and iron, and it's found right next to the entrance to the toll road at Stone Mountain Resort. In terms of factors as to why it's occurring, we have clear-cut trails, we have a large impervious surface, and we have townhouses that generally use fertilizers on their lawns. So this is what we're going to be looking for with your work today. Now, how do we get there? If we look at the sources document, you have one thing that you can take a look at, which is ArcGIS. ArcGIS, if you click on this link, will have the base map of land cover in terms of Vermont. Green is forested. The beige, yellowish, honey mustard color is cleared land. Red are buildings. Black is pavement. Gray is asphalt, and blue is water bodies. This will allow you to start looking for specific things associated with land use. Now, alternatively, as you start to explore locations, you can add any of these layers that are right here that will talk to you about impaired streams, residential sections, wetlands, impervious surfaces, roads that are at risk of erosion, or wastewater facilities. That will really help you start identifying specific factors and locations for water quality issues. There's also this interactive Vermont map that shows you different aspects: land cover, wetlands, water resources, utilities. And you can see that on this website. So that's another place you can get visualizations of your problem. Now, to start identifying where you might want to go to look for a problem, I have these sources here. This is going to be breaking down the historical levels of phosphorus entering Lake Champlain from different resources. This is going to be looking at the lake in terms of that image that we were looking at the beginning of class. This is going to be looking at different impaired streams. This is also going to be looking at different broad sources of nitrogen and phosphorus entering water bodies. Now this map shows each water part of Lake Champlain in terms of the breakup of different phosphorus sections. So what I would do is I would pick a segment of the lake that you think is in dire need of water quality management. Look at what are the aspects of wastewater developed for stream or agriculture in terms of phosphorus sources. And then maybe start looking in your two maps for locations within that watershed that might be a problem when it comes to phosphate sources entering. So for example, if I did Shelburne Bay, I would see that Shelburne Bay has a huge amount of its phosphate coming from agriculture. So I would look within that watershed and start identifying farms or agricultural practices that might be compromising water quality. And I would be putting that information right here for today. You don't need to worry about the problem or the solution. Please let me know how I can help. We'll be working on this next week in class as well.